Alright, so for number 6, they give me a reaction. And then they, ask me about my mole ratios. So first thing, get my equation. I have my equation. Second thing, find if it's balanced. Let me see if it's balanced. On the reactant side, I have aluminum, I have chlorine, I have sodium, and then I have CO3. CO3 is a polyatomic ion. I am just going to pretend that this is actually just a blue triangle. So I have a blue triangle on my reactant side. Product side, I also have aluminum, I also have chlorine, I also have sodium, and I have my blue triangle. On my reactant side, I have 1 aluminum, I have 3 chlorines, 2 sodiums, and just 1 triangle. Product side, I have 2 aluminums, I have 3 triangles, I have 1 sodium and 1 chlorine. So obviously these are not balanced, like these are a lot uneven. So let me start with the triangles, because this is all trial and error, right? So I have 3 triangles on this side and only 1 on this side. So I'm going to go and multiply this one by 3. Because I do that, I have to put my coefficient in front of this triangle, which is right here. So now the triangles are balanced, but putting this coefficient here also is making me multiply my sodium by 3. So times 3 is 6. And now I see that my sodium is unbalanced on this side. So I have to have a total of 6. I only have 1. So let me multiply that by 6. That means I have to put this coefficient in front of my sodium. And now this coefficient also multiplies into my chlorine. So my chlorine is also multiplied by 6. I can go on this side and be like, I only have 3 on this side. Let me multiply that by 2 to get 6, right? Because I have 6 on both sides, or need 6 on both sides. That means I need to put this 2 coefficient in front of my chlorine. But this one also multiplies into my aluminum. So 2 times 1 is 2. And now I have 2 aluminums on my reactant and product side, 6 chlorines reactant product, 6 sodiums reactant products, and 3 triangles on both sides. And now I'm balanced. So 2, 3, 1, 6. Alright, so now I'm ready to actually figure out what they're asking me to compare. If you react 8.01 moles of aluminum chloride, they want me to compare aluminum chloride. Aluminum chloride is this one right here, aluminum chloride. How many moles of the precipitate will form? Ooh, the precipitate. This means the solid. I have to be able to recognize that that's the solid. Luckily for me, they already told me which one that was. I can look at the states of matter on my products. I have an aqueous one, and I have a solid one. So my precipitate is the solid, so they're asking about this one. So they're asking me to compare these two things. I already know that the ratios are 2 AlCO3 for every, right, because those are 2 right there, for every 1 Al2CO3, wow, this is long, 3. 2 to 1, that's my ratio. So if I can tell myself, or commit, that I will always put aluminum chlorides on the top and my precipitate, which is a really long equation, at the bottom, I can set up a ratio fraction. So for every 2 aluminum chlorides, I am going to have 1 precipitate, and I can set that ratio equal to these moles that they want me to find. So if I react 8.01 moles of aluminum chloride, so 8.01 moles of aluminum chloride, how many moles of the precipitate? So what is this? And now I can do my pretty butterfly where I multiply 8.01 times 1 is 8.01 is equal to, and then I multiply this side, make a pretty little butterfly, 2 times x, which is 2x. I need to solve for x, so I can divide both sides by 2. And then I can take my handy dandy calculator and be like, what's 8.01 divided by 2? 4.005 is equal to x. They don't tell me to round to anything, so I can just leave it as this, or I can round it up to 2 decimal places like this one was. So I might do that. I'm just going to leave 2 decimal places, which means that this is approximately equal to 4.01 moles of precipitate, which is Al2CO3, 3. And that is my answer. Oh, there it is. That's my answer.